Breathe deep. Now imagine standing here, where there is no air to breathe. We are at an altitude of 8,848 meters, the flight altitude of a Boeing 747, where the atmospheric pressure is only 1/3 of sea level. This is the roof of the world, Everest. But our story today is not about the conquest of this peak. Our story is about a bigger secret, a secret hidden in the rocks beneath the climber's feet. Do you believe that the highest point on Earth was once the deepest point of a tropical ocean? And do you know why the human body at this height practically starts to eat itself? Welcome to the Terra channel. Today we are decoding the science behind the legend of Everest. Let's turn back time. Not 100 years, not 1,000 years, but 50 million years. During the Eocene epoch, the Earth was not at all like it is today. India was a huge floating island that was being smashed into the Asian continent at an incredible speed, about 15 centimeters per year. Between the two land masses was a huge ocean called the Tethys Sea. When India collided with Asia, one of the most dramatic collisions in Earth's history occurred. Neither tectonic plate was willing to go under the other. What was the result? The Earth's crust was crushed, broken, and pushed skyward. The Himalayas were born. But where is the evidence? If you went to the top of Mount Everest right now and picked up a piece of rock, you would find something strange. That rock is not volcanic. That rock is marine limestone. Yes, you heard that right. At the highest point on Earth, there are fossils of trilobites and sea creatures, crinoidea, that lived on the ocean floor 400 million years ago. Mount Everest is actually the floor of the Tethys Sea, propelled into the sky by tectonic forces. And the scary part? The accident isn't over yet. India is still pushing, and Everest is growing about 4 millimeters taller every year. This mountain is alive. For centuries, the local Tibetans called it Komolungma. But how did the scientific world recognize it? In the 19th century, the British launched a massive trigonometric survey of India. They thought that Mount Kanchenjunga was the highest. The unsung hero of this story was a brilliant Indian mathematician named Rabindranath Tagore. Not on the mountain, but in a dusty room in Calcutta, he discovered, through complex mathematical calculations, that Peak 15, the former name of Everest, was the highest point on Earth. In 1865, the mountain was renamed in honor of Sir George Everest, a former surveyor of India. Ironically, George Everest himself was against this naming, and even more interestingly, his name was correctly pronounced Everest, not Everest. Now, let's get to the dark side of the story, where biology fights for survival. The death zone. From 8,000 meters up, the laws of life change. At this altitude, the percentage of oxygen in the air is the same as 21%, but the air pressure is so low that oxygen molecules do not enter your blood. To compensate, the body thickens hemoglobin, which causes blood to clot. Fluid can leak into the lungs, HAPE, or the brain, ASE. In effect, in the death zone, your body is slowly dying. You cannot digest food. It is impossible to sleep, and every step is like running a marathon. That is why more than 300 bodies remain on the mountain. At that altitude, there is not enough energy to bring them down. They have become part of the geography of the mountain. Everest is not just a mountain. It is a natural laboratory, where the ocean reaches the sky and the biological limits of man are challenged. This peak reminds us of how dynamic, powerful, and yet ruthless our planet is. What do you think? Despite the deadly dangers and environmental problems, should humans continue to climb Everest, or should we leave this sacred place alone? Write your opinion in the comments. This is the Terra channel. If you like this scientific journey, like the video and hit the subscribe button to join us on the next adventure. Take care of yourself and the Earth. Goodbye.